Everybody. In this question, we have to explain about Fraunhofer lines and how they can be used to identify elements present in the sun. Now, showing on your screen is an example of the solar spectrum. It is a spectrum of the sun which we have received on the earth. On this spectrum, you see that there are some dark lines. I am just showing it to you. This is a dark line. This is also a dark line. This is also a dark line. On a continuous spectrum, we get a set of dark lines. These dark lines on a solar spectrum are called Fraunhofer lines. So all these dark lines which you are seeing on a bright background are called Fraunhofer lines. So what are Fraunhofer lines? When the spectrum obtained from the sun is examined, this is a spectrum obtained from the sun. It consists of a large number of dark lines. These dark lines in the solar spectrum are called Fraunhofer lines. Now, why are these Fraunhofer lines formed? To understand this, keep in mind that these Fraunhofer lines, these dark lines, are dependent on the property of the medium. Whenever a radiation passes through a medium, then medium absorbs some of the radiation. So these dark lines are formed due to that absorption by the medium. So the thing which we need to keep in mind is that these dark lines depend on the medium. They depend on the medium. So the question arises, how will the Fraunhofer lines help us in identify the elements present in the sun? So to answer that, I have to say that whenever we get the spectrum, the solar spectrum on Earth, we get some Fraunhofer line. By looking at these Fraunhofer line, we can find the wavelength which has been missing from the continuous spectrum. Now, according to the theory that we have just discussed, these missing wavelengths will be the property of the elements present in the sun's atmosphere, because that's where the absorption must have happened. So we counter check our data and find the elements which correspond to these dark lines. So that's how the Fraunhofer lines can help us to identify the elements present in the atmosphere of the sun. Hello everybody. In this question, we have to write a very short note on Ampere-Maxwell law. Now, Ampere-Maxwell law is basically the modified form of Ampere-Circuital law, which we studied in magnetic field. Now, this law relates the magnetic field around any closed path to the conduction current and the displacement current through that closed path. Now, Ampere-Maxwell law states that integral B dot dl over a closed path is equal to mu naught times IC plus ID. Now, in this equation, IC is the conduction current and ID is the displacement current. So basically, the Ampere-Maxwell law, it shows that both conduction current and displacement current, they both produce a magnetic field. Now this statement, this mathematical relation is known as the Ampere-Maxwell law. Now we know that the displacement current ID is equal to epsilon naught times rate of change of electric flux, which can be written as d phi E by dt. In this equation, phi E is the electric flux, so d phi E by dt will represent the rate of change of electric flux. Now I'm just putting the value of ID from the second equation into the first equation. So we get the Ampere-Maxwell law as integral B dot dl over a closed path is equal to mu naught times IC, I'm just writing as it is, plus ID I am putting as epsilon naught times d phi E by dt. Now just simplifying it for one more step, we get integral B dot dl over a closed path is equal to mu naught IC plus mu naught epsilon naught d phi E by dt. Now this last statement which I have written is known as the Ampere-Maxwell law. or it can be called the modified form of Ampere circuital law. So I hope you understood the solution. Hello everybody. In this question, we have to explain why electromagnetic waves are non-mechanical in nature. First, we should know what are non-mechanical waves. So basically, any kind of waves which do not require a medium for their propagation are called non-mechanical waves. So for non-mechanical waves, medium is not required for the propagation. Now the question arises, why are electromagnetic waves non-mechanical? Why they do not require a medium for their propagation? So answer to that lies in the fact that in electromagnetic waves, both electric field and magnetic field vibrate perpendicular to each other. So let me just write it down. Electric field and magnetic field both vibrate. Now we know that whenever the electric field in a region is varying, it produces a magnetic field, and the opposite is also true. Whenever the magnetic field in a region is varying, it produces an electric field. So due to the variation of electric field and magnetic field, a further magnetic field and electric field get produced, and that gets propagated in the medium. So for the propagation of non-mechanical waves, medium is not required because the wave can propagate altogether due to the variation of these electric field and magnetic field. So the reason why non-mechanical waves, electromagnetic waves are non-mechanical in nature, it is due to the simple fact that they propagate due to the variation or due to the oscillation of electric field and magnetic field. Hence, electromagnetic waves are non-mechanical in nature and do not require a medium for their propagation.